So today we come to chapter 3, freely falling object. We have learned the equations to describe motion along a straight line. We say if an object is moving with the initial velocity v0, acceleration a, that's constant acceleration, and reaching a final velocity v during certain amount of time t, and it travels a distance d. Then we have a group of equations to describe that motion. We say the final velocity will be equal to initial plus acceleration times time. And we have the distance equal to v0t plus 1/2 acceleration times t squared. We also have the third equation, which is the distance equal to the average velocity times the time. So those are the three equations describing the motion along a straight line. Now we come to chapter 3. In chapter 3, we're going to talk about a real case. An object moving along a straight line. That's a freely falling object. So the falling object has acceleration due to gravity. The magnitude, which is the value, is g, that is 9.8 meter per second squared. So this is a review. We don't have time to go to details. You should know this is called acceleration due to gravity. So g is always a constant. It's 9.8 meter per second squared. So that describes the object that falling down to the ground with acceleration equal to g, which is 9.8 meter per second squared. Well, the falling object has many different cases. We first talk about the free fall, which is the object just released from rest. Well, before doing so, I want to remind you that the object moving down is still be the motion along a straight line. In that case, it will be the object moving along the y direction or vertical direction. So all the equations we learned actually could apply to that case. Okay? So those equations will become to the same thing as what we have learned. It will become to different forms in different cases. Let's first talk about free fall, which means the object just falling down to the ground with the initial velocity 0. In that case, acceleration will be equal to g. And you're going to apply the equations we learned. Okay, suppose you want to find what's the final velocity and how much distance it goes during a certain amount of time t. You see, that's the same setup we have like what we learned in chapter 2. Then the equation will be the final velocity equal to v initial plus gt, because acceleration is g. And with 0 is 0, then eventually you got the phi law equal to g times t. And then you apply the same for the distance. The distance equal to, with 0 plus 1/2 gt squared, well, with 0 is 0, then you got a distance equal to 1/2 gt squared. So those are the two equations for free fall. Now let's come to the second case, which is the object is thrown down, which means it has the initial velocity going down not be 0, and we still need to find out what's the final velocity and what's the distance after a certain amount of time. In that case, you apply the equation, you have the final velocity equal to v0 plus g times t. And you have the distance equal to v0t plus 1/2 gt squared. And then we have the third case, which would be the object is throwing up. In that case, we have to know we have to see that the object, when it's thrown up, the acceleration due to gravity is actually trying to reduce its velocity. So then the acceleration is actually, you should put a minus g, because if you have initial velocity going up, the acceleration trying to get it down, which is a equal to minus g. So the equation will be v equal to v0 minus gt, because a equal to minus g. And the distance will be v0t minus 1/2 gt squared. Those are the equations for throwing up.